Welcome. This is the Ag Engineering Podcast, where we talk tools, tips, and techniques to improve the sustainability of your farm. I am your host, Andy Chamberlain from the University of Vermont Extension, and this podcast is supported by Northeast SARE, providing grants and education to advance innovation in sustainable agriculture. We're trying to improve the industry by chatting with farmers and getting their input on tools, tips, or techniques that have changed the way they farm for good. Many of these practices affect multiple areas of the farm. Whether it be environmentally, emotionally, physically, or financially, we share the knowledge to promote sustainable agriculture, lifestyle, and business. Thanks for having a listen. Now, let's get started. Today's episode comes to you from a farm in Moncton, Vermont, where we meet with Silas of Last Resort Farm. He grew up on the farm, but has been farming more actively the last 8 years and even more actively the last 3 seasons now that he's signed a lease-to-own agreement. This farm does 80 acres in hay, 15 to 20 acres in fruit, vegetables, and cover crops, and currently have 3 30 by 72 high tunnels with 3 more on the way. Their markets are wholesale, retail, farm share, as well as a farm stand, and they're bringing in between $200,000 and $300,000. Silas Doyle-Burr, welcome to the show.
Thanks for having me, Andy.
So I just painted the picture of your farm. How would you describe what you do in one sentence?
I describe the farm as a small-scale, diversified, certified organic fruit, veggie, maple, and hay farm.
Today we want to talk specifically about your storage conditions and how you do winter storage crops.
Yeah.
As well as, temperature, humidity. Going to get into the details on that. So
let's do it.
Yeah. Tell me a little bit about your cooler situation.
Sure. So this was last year, we finished up a brand new wash and pack facility that was retrofitted into. So we were a dairy farm till I was 6 years old, and then sold the cows, and my mom helped transition the farm into certified organic fruit and veggie operation. And our wash and pack facility was run out of the old milk house, and we also were using that as a farm stand as well. And so there were some issues with flow, as you can imagine, but the scale was a lot smaller, so it did work. Since I took over 2.5 years ago, been looking at a different scale, and so this new facility is on 1/2 of the barn. It's roughly 60 by 30 footprint, and now houses 4 walk-in coolers. In addition to the previous, we had a CoolBot controlled walk-in cooler that was about 370 cubic feet. In this new facility, 3 of the walk-ins are about 460 cubic feet, and then and those are all CoolBot controlled. And then we have one that's a little over 500 cubic feet, and that is split refrigeration. So it has a compressor and condenser unit.
And what made you just make the decision to use CoolBots on all of those but one?
Initial cost, really. And so utilized a lot of help from you guys, really. So Chris and you, and you probably got really sick of me knocking on your door or phone calls. But it was the idea with the 5 zones was to match, so 27 crops. That's a huge mix. All have very different requirements. And so we wanted to make sure that we were covering all our bases in terms of, warm, dry, warm, humid, cool, dry, cool, humid. With the CoolBot control is obviously cost, much less expensive. I think brand new, they're $350, $360 in that range. Then you have to get a AC unit, depending on the size, and their CoolBot's great to work with. And then also getting you or Chris to to the numbers also helps. But you're looking at, I don't know, $1,000 to $1,200 maybe if you include installing fees. If you're not doing it yourself, but you certainly can do it yourself. Versus the compressor and condenser unit that was a cost of probably. I think total about $7,000. So pretty significant difference.
Yeah, that's a big difference.
And there are some studies out there, if you just Google, just to see sort of CoolBot versus commercial units. One that surprised me is the commercial unit doesn't actually use that much more electricity. And then the other is, so a big crop of ours is strawberries, and we do a fair amount of perennials. So raspberries, blueberries, and then a fair amount of, just for retail. We don't wholesale any greens, but greens are an important mix to our crop list. Getting field heat out is huge for us, and the CoolBot units, especially midsummer, just really don't cut it. Even we have our largest unit is it's a 240 volts. I think it's 240,000 BTU. 24,000. 240. It's a 24,000 BTU unit, and that really struggles. And to get to, we set it at 36, but that's really, that's just a wish. I mean, it gets constantly to maybe 40, and so it's a nice backup. Like we've had issues with the commercial unit. The controller broke on it, and it froze tomatoes solid. Thank goodness we didn't have thousands of dollars worth of strawberries in there, but I think we had a couple. It was still not a fun day because we ended up having to make a lot of tomato sauce. And what's tended to happen for us is that it's getting the set bandwidth for the commercial unit has been tough to get it to be a consistent temperature. We've gradually dialed that in, and but that's something where it's kind of hard to work on yourself. So if you're looking to do everything yourself, a CoolBot controlled unit is the way to go. But again, removing field heat and getting a consistent temperature as close to 32 as possible in the dead of summer, you really have to have a commercial unit.
So when you were weighing out your options, you're like, okay, I want multiple zones to have multiple different crops in ideal conditions.
Sure.
You can do that via CoolBot rather easily, fairly cheaply. And then you decided you wanted one cooler where you could really remove the field heat and get a nice icy cold, not quite icy, icy cold temperature.
Use that word.
Unintentionally icy tomatoes. No. How did you find an installer for that commercial unit?
So we just luckily we have several neighbors who are the husband of my babysitter is an HVAC guy and did a great job. And then the neighbor who is from the family that my folks bought the farm from is a plumber, and so he's done a lot of work on those units as well.
Nice. So know your neighbors.
Yeah,
so.
Exactly.
So you have multiple zoned coolers, which is super cool. I mean, a lot of farms don't even have a cooler, and if they do, they're they got one cooler set at 40 or whatever, and hope that it works best for most crops.
Yeah. Refrigerator style.
Yeah. How do you manage all of these? Are you going in and out of coolers or?
Yeah. Right. So when you have multiple zones, the old open the door check really doesn't cut it. And also for me, so I live off farm, adding a little bit more to the stress because especially during berry season, we can have lots of money in there. And if we were to have an icy incident, as we had with the tomatoes before, it would just be devastating. So what we did when we installed all of the walk-ins is we also, and all the CoolBots and the condenser unit was worked with another neighbor, Bill Coons, from Vermont Energy Control Systems. And he's actually Chris Callahan, I think, his technology for what he calls the do-right sensors. So these sensors can measure temperature and humidity, relative humidity. Kind of groundbreaking technology, right?
Yeah. So a little bit about the do-right is it's a humidity sensor that has really good accuracy at really low temperatures and really high humidities. Mm-hmm. So there's a lot of humidity sensors out there, but their range of accuracy kind of goes out to lunch, A, when it gets really high humidity, and B, when it gets really cold, which is a cooler environment. And when you're talking 95 to 99% humidity at 32 or 33, 34 degrees, it's really important to have that dialed in. So that's something that, yes, my colleague Chris Callahan
Yeah.
actually kind of designed, and then he partnered with VECS to bring that to commercialization. So
Sure, yeah. And, so it's been working great. We have do-right sensors in each one of our 5 zones, and those are connected to, so we have 2 Vesta controllers that Bill Coons makes. And what's neat about these controllers is, one, so it's connected via, Cat5 to our network. And so on the computer, I can just pull it up. On my iPhone, can pull up at any time. So it'll be tracking temperature, humidity. And then also we installed relays. So that relays to different GFI outlets, where if we want to heat or we want to humidify, dehumidify, depending on what the parameters are that we want to reach. So if we want to get it up to 70 degrees, then the relay will turn on until it gets up to that point. You can change that with a click of a button. There is a bit of a learning curve with this setup because so Bill Coons, I think he's in his 3rd, 4th year with working with these, at least it applied to agriculture. And so I've had to learn, the logic rules for coding, and that's been kind of an adventure. And so that's why this system might not be for everybody. So there is some hands-on, and it's just, it works out great because Bill's just down the road. And so if there are any issues that come up, the do-right sensors for the most part have worked pretty well. But there have been some minor hiccups, and there is some maintenance. So you have to maintain the water level with the wick, and you'll be pairing pictures with these so people will know. And so, yeah, I know that there are other systems out there that maybe are more user-friendly, where you can just kind of more turnkey, which I think would be like a Monet system or...
Yeah, there's a couple others out there. So this is not plug-and-play system.
Right. It's getting to that point, and Bill's customer service has been phenomenal. So it's definitely an option to look into. And I think what's neat about this is you can then, with these controllers, if you have extra space for other sensors or probes, you can then hook them up into your greenhouse, or it can extend to wherever you have parameters that you want to measure. And so, yeah, it's kind of important part of the toolkit of making a smart farm.
Yeah. Does he offer wireless solutions for like adding sensors to greenhouses, or do you got to run Cat5 all over your farm?
He actually recommends not running Cat5, Cat5 wire, because I guess there are lightning issues where you'll bury the line, and if it gets struck, then all that line is fried. And so he has recommended wireless. We haven't really discussed more about that, so that's something that I'll have to get back to you. Come back and we'll do a wireless episode.
Sure. Yeah, no, that'd be neat. How about the cost? Was it affordable? Is it justified? You still paying on that?
I think we're talking roughly $3,000 for everything.
Roughly $3,000 to set up 5 coolers.
5 coolers,
all remotely monitored.
Yeah.
And you can change the parameters on your phone too? Or?
Yes.
Okay,
yeah.
sweet.
You can actively do it. Yeah. And he sets up a control page. So if you're not comfortable with creating new rules, he can do that for you. I'm not sure what the added cost would be on that, but like if you have a template. The problem is that if you're a growing farm, which I think pretty much everybody, you can't just stay stagnant, or maybe you can, but I'd be curious to see that. And I mean, that's amazing. Good for you. But if you're changing things around, which is pretty constant on our farm anyway, you can't really have a set template and stick to that. So yeah, that's why this may not be the best in terms of just like a turnkey setup where, you just buy another sensor and then you're set. You have to be able to learn the rules, which involves just true false logic, and then also what does dead span mean? And
I have no idea. So obviously,
gotcha.
Customer service is an important
key.
part.
And if you check out his website, he has a full manual on sort of what are these rules and what does deadspan mean? I mean, and then again, YouTube too.
Yeah, I was going to say, are you up late watching YouTube videos trying to educate yourself on logic, or did he kind of teach you what you needed to know?
Yeah, I mean, he taught, and the other thing is that once you have one rule in place, you can kind of reverse engineer it. And so, yeah, I mean, I spent 2 years in China. I got pretty good at reverse engineering things. And yeah, so I'd be happy if people wanted to reach out to me about it too, if they had questions. I'd be fine with that as well.
Great. I will also say we'll have a couple pictures and actually a video walkthrough of his coolers. So you can check that out on our YouTube channel, UVMEXT Ag Eng. And those will be linked to our blog and to this podcast page at agengpodcast.com, so you can see what we're talking about there. Before we change subjects or wrap up the episode, I just wanted to go a little bit deeper, like explain what the relays are for those who aren't familiar with how are you controlling these remotely.
Sure. So basically it's low voltage signal where you set these parameters and the controller will send out a signal, and this relay, and you'll have a link to the picture, right?
Yep.
So people can see it, but there's an LED light on it, and so if the signal turns on, the light is on. If it's off, it's off, and basically the low voltage signal triggers the connection to either turn on or off for the high voltage, the 110/120 volts. And so as an example, we sprout ginger. That's one of our specialty crops. And so starting in March is when we get one of our walk-ins warm. And so we've actually been doing it above 75 degrees. And so if it's below that, you should see the light on the relay on if you set the parameters and you got the rules correct. And then once it gets past that point, and depending on what you set for the dead span, sort of how much do you want the temperature to fluctuate, it should go off once it gets beyond that temperature.
So a relay is a digital switch that's controlled via the program or your software, which basically turns on the outlet on or off at a certain set point.
It's a fantastic, way better way of putting it together. I guess you're an engineer. Are you an engineer?
I do some engineering, yeah. And so these outlets in your, well, they're not even coolers; they're controlled rooms. I mean, you just explained a propagation room or a germination chamber, really, which is super.
Yeah. We use them for grafting and all sorts of things. They're really multifunctional with this type of technology, which is great.
So you've got your CoolBot controlled into that relay switched outlet, or is that controlled separately?
No, yeah, that's separate. Yeah, so because they have their own controllers and their own sensors. So their own temperature probe. Yeah, what's unfortunate is all of the technology is not sort of all fits into one hat, which pluses and minuses to that. I mean, I guess it's good to have that diversity where if one thing fails, the Vesta controller fails, the CoolBot won't shut off. But at the same time, to check on the CoolBot, you sometimes have to open the door because there can be different zones and pockets in the walk-ins where the do-right sensor will read one temperature and the CoolBot will read another. I mean, I guess the only time that's really a problem, which has never happened with the CoolBot controlled unit, but if you're talking like getting down to freezing temperatures where that 1 or 2 degrees difference would really matter. So there's kind of small things like that just to consider.
So into your switched outlets, you've got the CoolBot and you've got a little heater in there.
So I've seen multiple ways that people do this. You could, if you're not using the relay, I think a cheap way to go get around that, as long as you have power, is you can use an Inkbird thermostat or something of that nature. And I think those are fairly cost effective too. I don't remember how much those are. But the relay's nice just because I don't have to be there. I can access it remote. Where the Inkbird, you got to walk in and out just a double check.
Yeah. Is there anything that you would wish you had done differently when setting up your controlled spaces?
I'm still not sure in terms of how long the material will hold up with the humidity, and that's kind of a concern. I guess I wish I had truss core everywhere in the washing pack, and so we use plywood siding. I guess in the pictures will better describe it, but in the specific washing area that's on one side of the drain, where most of the plan for where the water would be is all covered with truss core. But then where the walk-in storage is, there is some splash that gets on there, and then there's some mold that has developed. So we just try to keep things as clean and dry as possible. But it's a question of how long will this material last and hold up. And I'm also, it'd be a major project if we had to remove moldy, there's
Wall
a lot
materials,
of insulation, wall materials, the OSB, insulation. And so I guess what would be the best would be to have a concrete floor for each one of the walk-ins with a drain. And that's, if we're talking warm and humid, there's always going to be some moisture on the floor, and whenever we're washing, there's just not a place for it to escape. So for water to escape,
because these are custom built grow rooms, insulated floor, so plywood floor over the insulation. You've got to step up there because you're trying to squeeze this into the barn you've got.
And I have seen so you see like larger scale walk-ins, and those are concrete floor with drains, and just a lot easier to wash. The truss core has been nice though, and that's super easy to install, and it's easy to clean.
We'll link to some more information about truss core, which is a corrugated plastic panel that installs much like vinyl siding would, and it makes a nice, solid, washable, cleanable, waterproof surface in wash pack spaces. So I'll share some information on that as well.
One thing I didn't mention was we had talked about those dead zones or pockets that develop. I mean, our walk-ins are relatively small, but still we've noticed differentiation with what the do-right sensor is saying, what the CoolBot sensor, and then in one of the walk-ins we added an additional temperature probe just to see how different or what the range was, and it is pretty significant, up to 5 degree difference.
Wow. In
the same walk-in. And so adding some sort of circulation fan, or with the condenser unit, like that's the evaporator fans that are constantly on, and so you get nice circulation there. But with the CoolBot controlled units, you have the 8C unit, which is moving air around a little bit, but it's really inadequate. So I encourage everybody you do have a CoolBot controlled unit, make sure that you're circulating the air.
Add some circulation fans.
Yeah.
Cool. Silas, thanks for sharing about your controlled rooms and how you manage those. If people have questions and want to know more or talk to you specifically, how can they get a hold of you?
People can always follow us on Facebook, Instagram, can send direct messages on there, or the best way generally to reach me is to reach me at my email, which is silas@lastresortfarm.com, or you can shoot me a message through our website, which is www.lastresortfarm.com.
Awesome. Well, thank you.
Thanks for having me, Andy. It was a blast.
We'll chat later. Thank you for listening to today's episode. I hope you go ahead and subscribe, share this with a friend, or leave us a comment. And if you want more information, check out the show notes on our website at agengpodcast.com. That's agengpodcast.com. Thanks for listening. I hope you have a great day.
The proceeding has been a production of University of Vermont Extension. For more information on Extension, log on to www.uvm.edu/extension.